the quotient rule. In this rule, I'm looking at when I have a function in the numerator and the denominator, so a rational expression with a function with variables on both sides of the fraction. So this one gets a little more complicated than a product rule just by one more step. So it looks a lot like the product rule. So as a reminder, the product rule said that the derivative of f times g was derivative of 1 times the other function plus the function times the derivative of the other. The numerator of the quotient rule is very similar, except now we have a minus instead of a plus. And in the denominator, we have the original denominator squared. Notice we don't take the derivative of the denominator, we just square it. So there's a memory trick for this one. We call this guy the high function, or I call it just high. And the lower function, the denominator, we call the low function, or sometimes I abbreviate just low. And then I think, okay, so this is the derivative of the high function, and this is the low function. So it's a little different order written here, but so I'm just going to switch the order a little bit so I can do my little rhyme. So it's low function times high function derivative. So that's low d high minus high d low all over low squared. So that's low d high minus high d low all over the low squared. So let's see how this applies. So let's look at number 12. So this is my high function, this is my low function, and I want to rewrite this in terms of that formula. So that looks like low d high, so that's 1 plus 2x, that's my low, I'm not going to even write d high minus high d low all over low or low squared. Whoops. So now when I see these d's, those I'm going to take the derivative of. So the 1 plus 2x here, it doesn't change at all. I just keep that function as it is. And then the second function has the d in front of it, so that means I'll take the derivative of that one, which is 2x. Minus sign. The x squared, just take it by itself. And then the second function has the d in front of it, so I do the derivative of that one. So that's 2. And then the denominator, I don't take the derivative. I just rewrite it and square it. All right, now I want to simplify. So I can distribute this 2x into this parentheses, so I get 2x plus 4x squared, and then minus, and then 2 times x squared gives me 2x squared. I would have to distribute that negative if I had more than one term, but I only have one term, so that looks fine. All over 1 plus 2x squared. Again, the denominator, we didn't take the derivative, it's just the denominator squared. All right, and then I can cancel the 2x. Oops, no, I cannot. That actually, yeah, I can't. No, I can't, but I can combine these like terms, the 4x squared and the negative 2x, and that gives me 2x, 4x squared minus 2x squared gives me positive 2x squared all over 1 plus 2x squared. Then I can take that constant 2 out. So I have a 2 out in front, and the function x plus x squared over 1 plus 2x squared as my final answer.